For example 2, we'll try to do the limit as x goes to 0 of e to the 2x minus 1 over x. I would always recommend with a limit starting with attempting the limit with substitution. Whether you write it down or try it in your head, sometimes all you have to do for a limit is substitution, which means plug in the number. It works. So we'll try this one first. 2 times 0 is 0, e to the 0 is 1, so this one ends up being 1 minus 1 over 0, which is 0 over 0. That is an indeterminate form. And with an indeterminate form, you cannot determine the limit with what you just did. You will need to do something different. And our something different is going to be L'Hopital's rule. L'Hopital's rule is when you do the derivative of the numerator and the derivative of the denominator, and then try substitution again. So I'm just going to write LH, shortening L'Hopital's rule so you know what I'm doing. Limit as x goes to 0. I'm going to do the derivative of the top, which would be e to the 2x times 2 minus 0 all over 1. Now I'll try plugging 0 in again, see if it works. 2 times e to the 2 times e to the 2 times 0 over 1. 2 to the 0 is 0. E to the 0 is 1. So on the top I end up with 2. On the bottom I have 1. 2 divided by 1 is 2. So L'Hopital's rule worked on example 2. Let's try example 3. I am going to plug in 0. See what happens. So 16 minus 0 squared square root minus 4 all over 0. End up with square root of 16 minus 4. That would be 4 minus 4 on top and 0 on the bottom. I do end up with an indeterminate form. Indeterminate form means I can't determine what the limit is as is. I need to try something different. This is the type of problem where we would multiply by the conjugate if we were doing this algebraically, which is still an option for you. I am going to show you the L'Hopital's rule for the shortcut and see what you think. So L'Hopital's rule means I'm going to take the derivative of the top, the derivative of the bottom, and try again. So the derivative of the top, it looks like it would be, if I had that stuff to the half, it would be chain rule, bring that half down in front. 16 minus x squared to the negative half, multiply by the derivative of the inside, negative 2x. So that's my chain rule. Minus the derivative of 4 is 0, and the derivative of x is 1. Now I should be able to simplify and then try plugging in 0 again. On the top I have a half and a negative 2. I'm going to cancel out that half and that 2. I'll leave the negative. It looks like on the top I'll have negative x from that negative x, and then this I'll have to move to the bottom of that negative x. So it'd be 16 minus x squared to the positive half, and then that's all over 1. I still have to plug in 0 because of my limit as x approaches 0. So I think I'm going to try it and see what happens. So if I try it, I get negative 0 over 16 minus 0 squared to the half all over 1. So this one would be negative 0 is the same as 0 divided by 16 to the half would be 4, and that is 0. 0 divided by 1 is 0. So I end up with an answer of 0.